Anza.
How are you, students? I want to welcome you to this class, a chemistry lesson, and the area we're going to deal with is distillation. Perhaps it could be a good idea if we could start by defining what distillation is. Distillation is actually a method of separating mixtures. But the mixtures to be separated must be based on the differences in volatilities of components in a boiling liquid mixture. It is well known that different liquids have different boiling points. And basing our argument on their differences in boiling points, we can actually separate them using a method called distillation. Distillation in secondary school is learned in various areas. We meet distillation during the separation of components in crude oil, which can be used in areas such as transport, power generation, and heating. We also meet distillation during the separation of liquid air, whose components include nitrogen, oxygen, and argon. And these components are basically used for industrial use. For this lesson, I want to carry you through separation of ethanol, a mixture of ethanol and water. So I want you to follow me to a setup here. This is an apparatus which is set basically to separate a mixture of ethanol and water. And I want to first of all carry you through the apparatus that we have. The most important component is the dairy condenser. This is actually where condensation takes place. It's connected to a round bottom flask where we are putting the mixture to be separated. So inside here, we have a mixture of ethanol and water, and you can see they mix to form a uniform layer. You can also see some piping, like we shall be having water running from the tap, down the pipe, moves up the condenser and out. So the flow of water should be continuous during the process. We also have a Bunsen burner which will act as a source of heat. And on this other end, we are going to use a conical flask. This is where we will be collecting our distillates. So now we turn on the tap to get running water, slowly to get the running water. Now you can see water is moving. Water is moving. And it moves out. Water moves up the condenser, out. Water moves from the tap up the condenser, out. And that water should be made to run continuously. So now we heat, or we light the burner. To remind you the process of lighting the burner, we have first, you get the matchstick burning, turn on the gas and light the burner. Already the air hole is fully open so that we get a non-luminous flame which is hotter. So now we have the mixture is now burning. I want you to observe at what happens here. We shall discuss later on, but I want you to know that water and ethanol boils at different temperatures. One of them will boil fast. The one with the lowest boiling point, that is the one which will boil fast. And you can see it's already boiling. The boiling of the first fraction has already started. When the fraction boils, the vapor comes up through the delivery tube, comes to the condenser, the Liebig condenser. It will be condensed, and on this other end now you can see our first distillate coming out. Our first distillate is now coming out. This is the distillate of the fraction whose boiling point is lower, and in this case it is ethanol. At this juncture, when we are getting our first fraction, the temperatures are supposed to remain constant, though heating continues. The temperatures should remain constant until the first fraction is fully collected, and thereafter now the temperatures will start rising up to the boiling point of the second fraction, where you now start collecting the second distillate. And by that time, you are supposed to be changing the apparatus so that you prepare yourself to collect the second distillate. So that is basically what we have for distillation.